Okay, so we're going to go ahead and talk just a little bit more formally about some steps to take to write the chemical equation of the precipitation reaction. However, it's basically what I just took you through, just again in a more formal manner. So, you'll always be given the reactants. However, hypothetically, if need be, you may have to translate them from words to formula. So, remember, we know how to write the chemical formula of an ionic compound. So if I give you the name of the reactants, you would have to write the chemical formula of the reactants with the proper ionic formula first and foremost. And then, no matter what, you'll start at step 2 and swap the anion-cation pairs to that double displacement reaction. So once you know what the reactants are, you can go ahead, predict the products, swap those anion-cation pairs, and then check all of the products that are formed individually from each other to determine if they are soluble. So determine if those new products that you formed are soluble or not soluble. And remember, if all products are soluble, no reaction occurred. Once we swap our anion-cation pairs, we'll write the reactants down with their proper chemical formulas and states. We will write the products down with their proper chemical formulas and states. So if a compound is soluble, it's therefore in the aqueous state. If it's not soluble, it's in the solid state. So the only states we're likely going to use when we're talking about precipitation reactions are aqueous and solid. So remember, liquid only means it's a pure liquid, and if we have salt in water, it's no longer pure, it's an aqueous solution. Once we've written all of this out, we check the equation to see if it's balanced, and then we balance it if it's not already balanced. So it's basically just a culmination of everything we have been doing this far. Can we write a chemical equation? Okay, so let's do some practice. Let me get my iPad pulled up. Okay, so our first equation that we're going to want to fully write through is calcium chloride reacts with potassium sulfate to form what? And how do I write this chemical equation? So, I'm looking at the reaction of calcium chloride, potassium sulfate. The first thing that I do is go ahead and predict the products. So the first thing we need to do is predict the products. So if I have CaCl2, I'm going to take the calcium with the sulfate, therefore calcium is 2 plus, sulfate is SO4, 2 minus. So if I want to write the correct chemical formula of the products, I have CaSO4 as one of them. My other pair is the chlorine with the potassium. So I have K plus and Cl minus. So those are both a one-to-one charge as well. So we have KCl in this case. So our chemical reaction, when we have CaCl2 reacting with K2SO4, that goes ahead and makes us calcium sulfate and potassium chloride. So now we have our products properly written and our everything ready and predicted. The next thing we need to do is to determine the state of the products. So I need to check the calcium sulfate and check the potassium chloride to see if they are soluble or not. So I'm going to go ahead and look for calcium or sulfate on the left-hand side of our table over here. Calcium sulfate. So sulfate is SO4, and I am going to assume that it's always soluble unless it's with one of these compounds that make it insoluble. So therefore, calcium sulfate is what we have. Calcium is one of the insoluble salts with sulfate. So calcium sulfate is not soluble. So this is not soluble and will be in the solid state. Remember, those calcium and sulfate ions are floating around in solution. They're going to knock into each other, and they're going to fall out as a solid. We have potassium chloride as our second product. We need to determine if that's soluble. You should have two big hints right away. We've got potassium, which is a group 1 alkali metal. It's soluble. We don't even have to think twice. But the halogens are also very soluble, except for in very specific cases. So KCl is always going to be soluble, so soluble. and that's going to therefore be in the aqueous state. I can spell aqueous, A-Q-U-E-O-U-S. Aqueous state. Okay, so using the information that we have now gathered, I'm going to go ahead and fully write out the reactants with their states, put the arrow in, write the products with their states, and make sure everything that's supposed to be is separated by plus signs. Okay, so now we're going to go ahead and write everything out properly, all the reactants, all the products with the states. So I'm going to leave a couple of spaces for my coefficients, but I have CaCl2, that is in the aqueous state, reacting with K2SO4, that's in the aqueous state, and that produces calcium sulfate in the aqueous, or in the solid state, sorry, calcium sulfate is a solid, and that produces potassium chloride, and that's in the aqueous state. Sorry, I ran out of space there. I wanted to leave some spots for my coefficients eventually. So let's go ahead. The next thing we need to do, once we have it all wonderfully written out like this, we need to determine if this chemical equation is balanced. So I'm just going to check a couple of the elements right off the bat to see if I can find a glaring hole where something isn't balanced. So looks like I've got 1 calcium on both sides. However, if I check out the chlorine, I've got 2 chlorines, 1 chlorine. Looks like we're going to need to do some balancing. So I'm going to go ahead and write out each kind of element I see on both sides. Calcium, chlorine, potassium, sulfate, or sulfur, and oxygen. Over here we have calcium, chlorine, potassium, sulfur, and oxygen again. And now let's count them up on both sides. On the left-hand side, I have 1 calcium, 2 chlorines, 2 potassiums, 1 sulfur, 4 oxygens. On the right-hand side, I have 1 calcium, 1 chlorine, 1 potassium, 1 sulfur, 4 oxygens. All right, so let's go ahead and balance this chemical equation. So if I'm looking at what I have going on here, we tend to start with metals, and I tend to look at what needs to be balanced first. So I see that it's kind of my calcium and my potassium, or my chlorine and my potassium that are not adding up. So I'm going to go ahead and choose between the two of those, of which I should try to balance first. Well, potassium is a metal, so I'm going to look at potassium first. I've got 2 potassiums on the left-hand side and only 1 on the right-hand side, so I'm going to add a coefficient of 2 on the left-hand, or on the right-hand side to try to balance that. So let me calculate my products again, count up those numbers. I have 1 calcium, I have 2 chlorines, 2 potassiums, 1 sulfur, and 4 oxygens. So let me tally this up, see what we got going on. Are we balanced? Looks like I've got 1 calcium on each side, 2 chlorines, 2 potassiums, 1 sulfur, 4 oxygens. We are balanced. So our properly balanced chemical equation looks something like this. CaCl2 in the aqueous state reacts with K2SO4, aqueous, to make calcium sulfate in the solid state and 2 potassium chlorides in the aqueous state. So that is what our properly written chemical equation looks like. It's up there on the screen for you as well. So we have now fully gone through together, written out and balanced a chemical equation. Look at us go. I'm so proud of us. So we wrote this equation all by ourselves. Thank goodness. We feel like real chemists. Now let's go ahead and do another example while we're at it. So we're going to go ahead and work through another example here that you see up on your screen. We have barium oxide reacting with lithium sulfide. We're going to determine the products of these reactions and see where to go from here. So remember, the first thing that we do is we predict our products. So what are the products of this chemical reaction? So I have barium oxide, so I'm going to pair the barium with the sulfur. So I've got Ba2 plus, and I have S2 minus to make this product. So it looks like that's balanced. So I would have BAS. Those have equal charge. And the other one I have, the other pair is lithium with an oxygen. So I have lithium 1 plus and oxygen 2 minus. So I'm going to need to make sure that I write this ionic formula correctly. So therefore, I need 2 lithiums to make 2 positives to balance out my oxygens, 2 negative charges. So we have Li2O in that case. So now we know what our products are. Our products are BAS and Li2O. Those are our 2 sets of products. Now we need to determine if they are soluble in water or not. So we're going to go ahead and check our handy-dandy chart. Our handy-dandy chart looks like I'm going to start looking for barium or sulfide down here. Sulfide. Sulfide is usually insoluble unless it's with group 1 or ammonium. However, barium is actually an alkaline earth metal. It's in group 2. So it does not count in these exceptions. So therefore, barium sulfide is insoluble. Not soluble will be in the solid state. So this is not soluble, solid state. I have lithium oxide. I need to determine if that is soluble. I swear to God, if you have not heard me say lithium is soluble this entire time, and you're thinking twice about this, what are you doing? So if I need to check my chart, I can check my chart. I see that anything in group 1 is always soluble. Lithium oxide is going to be soluble in water. So lithium oxide, soluble. So when it's in the products, it's going to be in the aqueous state. Okay, now we've used our reactants to predict our products. We've determined the state of those products. We can go ahead and write out our equation. So let's do that now. So we have barium oxide in the aqueous state. Reacts with lithium sulfide in the aqueous state to form barium sulfide, and that was in the solid state, and lithium oxide in the aqueous state. Okay, so we need to determine next, now that we have this all written out in a beautiful manner, if this reaction is balanced. So I'm going to go ahead and write down each kind of element I see. I see barium, I see oxygen, I see lithium, I see sulfur. I see the same things on the other side. So let's go ahead and count up our atoms, determine if this is balanced. So barium oxide gives me 1 barium, 1 oxygen. Lithium sulfide gives me 2 lithium, 1 sulfur. On the product side specifically, I have barium sulfide, so I have 1 barium, 1 sulfur. I have lithium oxide, which gives me 2 lithium, 1 oxygen. So I have 1 barium, 2 oxygen, or 1 oxygen, 1 oxygen, 2 lithium, 2 lithium, 1 sulfur, 1 sulfur. We are balanced. Check. So there's no need to go through thinking about doing any sort of balancing here. We can just go ahead and write down our final equation as barium oxide in the aqueous state reacts with lithium sulfide in the aqueous state to make barium sulfide in the solid state with lithium oxide in the aqueous state. In the aqueous state. So this is our final chemical reaction here for this instance. So That being said, I've left you with some practice of your own. I've written out all the steps for you for each of these problems. Check it out. Please work through them. They have some important points that might be made, some great practice of predicting those products as well. So please, please, please work through those. They're going to be a great help for you when we're talking about actually writing the chemical equation of a precipitation reaction.